All right, these first two questions are a review from yesterday with graphing using a T-chart. I'm not going to go through all the math here as I do this. You should have done that on your paper. This is just for you to check your answers. So if I do a T-chart, my X, my Y, -2, -1, 0, 1, 2. My Y value should have been 2, 1/2, 0, 1/2, 2. So that when I graph this, it should look something like this. The second one, y equals -2x squared. Again, if you substituted those values in, your y value should have been -8, -2, 0, -2, -8. And when you graph that, your parabola should look something like that. Again, that's just reviewing the skills we went over yesterday. Today we will look at more graphing. And we won't have to do a full T-chart. We'll still do a small T-chart, but there's some other things that we're going to have to take into consideration today as we look at this. So as we're building our knowledge of quadratic functions here, we talked about axis of symmetry yesterday. I just want to add it to our official list of terms and define it. So axis of symmetry and I will abbreviate that as capital AOS as we refer to it, is the vertical line that is drawn through the vertex of the parabola. Vertical line that is drawn through the vertex of the parabola. In other words, this is what cuts the parabola in half. And we'll be marking the axis of symmetry and using that information as we go through some of today's problems. So again, we talked about axis of symmetry yesterday, but we didn't add it to our official list of terms. So now we've got it defined, what it does. Some other terms that we're going to add. We're going to talk about the standard form of a quadratic. Standard form of a quadratic. And you actually already saw this form in Unit 1. The standard form of a quadratic is y equals ax squared plus bx plus c. Now, we will deal more with that form when we get to Unit 3. We deal with it a little bit in Unit 2, but standard form is more Unit 3. The form that we're going to spend some time on in this unit is called the vertex form of a quadratic. And in this form, this is where we had a and k yesterday, and we're going to add another variable. This is y equals a times the quantity x minus h squared plus k. And we'll do some review on what A and K were. We talked about those yesterday. We'll do some review on that. And then we'll talk about what does H do? How does that affect the graph? So remember, A determines which direction it opens and how wide or narrow. Determines which direction it opens and how wide or narrow. And again, that's out in front of the parentheses there, the x minus h. We also talked about k yesterday. So k, if we remember, is our vertical shift. It determines our vertical shift. And again, these two are a review from part A. We went over these yesterday. So those are not new. We talked about both of those yesterday. We looked at that for the homework last night. What is new today is now we've added in this H. So I am adding a new letter in. So H determines our horizontal shift, or how far left or right the graph shifts. So it determines the horizontal shift. Or how far left or right the graph shifts. And now H and K together also have a relationship as an ordered pair. So the ordered pair H comma K is the ordered pair representing the vertex of the parabola. The ordered pair representing the vertex of the parabola. And just as a little side note here for this one, the vertex is always on the axis of symmetry. And remember, I'm abbreviating axis of symmetry as AOS. So now there's several pieces of information. If the equation is in vertex form, there's several pieces of information that we will be able to get from that. All right, so now we're getting back to graphing, but now the graphing is going to be different. We can't just do that T-chart with the same 5 numbers because these graphs are now shifting left, right, up, down. So we have to know what our vertex is. As a reminder, the vertex form is y equals a times the quantity x minus h squared plus k, because we're going to need to identify our a, our h, and our k to be able to graph these. A will tell us what direction it opens. H and k will give me the ordered pair for the vertex, and will also tell me where the axis of symmetry is. That's going to become important as we do this. So the first one, y equals the quantity x plus 5 squared. Couple things. Remember, if there's nothing out here, it's like there's a 1. And if there's no plus or minus number, we can just say it's like saying plus 0. That way we still have an a, an h, and a k. So in this case, a is equal to 1. Now with h, this is where you have to be cautious. The equation says x minus h. So if there's a minus inside, h is actually positive. If there's a plus inside, h is negative. This is where people usually get tripped up because a and k are just like we see them. H is opposite. So in this case, h would be positive 5 because it's minus 5. And k would be 0. So those two together make up my vertex, which again is the ordered pair h comma k. So my vertex would be 5 comma 0. Just putting those 2 points together as an ordered pair. So I graph that. There's 5, 0. And now I know my axis of symmetry, or the line that cuts my parabola in half, is going through that same line. So I'm going to draw in my axis of symmetry as a dotted line. So again, that is my axis of symmetry. Now here is where we have to go back to yesterday. We still have to find a couple more points. First off, though, if I look at A, is this going to open up or open down? If A is a positive 1, does this open up or down? Yeah, if it's positive, remember, this is going to open up. Now, this is where, add a little note off to the side. After you graph the vertex as an axis of symmetry, you're going to pick 2 points, one on each side of the axis of symmetry, to substitute into the equation to help you get the shape of the graph. So let's add that note. After you graph the vertex and axis of symmetry, pick 2 points one on each side of the axis of symmetry, to substitute into the equation to get the shape of the graph. So we do have to do a mini T-chart here, but we only have to do 2 points instead of the 5 we did yesterday. And we base those 2 points on our axis of symmetry. Our axis of symmetry is going through the x-coordinate 5. So for my T-chart, I'm going to go 2 units to the left of the 5 and 2 units to the right. You don't have to do 2. You can do 3. You could do 4. The problem is if you go too many units on either side, you might end up off the graph. So if my axis of symmetry is at 5, 2 units to the left would be 3. 2 units to the right would be 7. Now, by picking ones that are the same distance away, because this is symmetrical, they should get me the same y value when I solve. So this is a good way to check that I'm doing my math correctly. So if I substitute 3 in, I have y equals 3 minus 5 quantity squared. So negative 2 quantity squared, which is positive 4. Do the same thing for the 7. Y equals 7 minus 5 quantity squared, which gives me 2 squared, which is 4. So that does work out. I expected them to give me the same answer. So I graph 3, 4 and 7, 4. And now I have some points to help me with the shape of my graph. All right, so the next one, y equals the quantity x minus 3 squared plus 2. So again, if there's nothing out in front of that parentheses, we have to remember that's going to be a 1. So A equals 1. Again, since it says x minus 3, that means that h is a positive 3. And it's a plus 2 at the end, so k would be a positive 2. So what would be the ordered pair for my vertex here? If h is 3 and k is 2, what is my vertex? 3, 2. So I graph that point. And again, that also tells me where my axis of symmetry is. So I know that the line that's cutting my graph in half, which helps me with my t-chart. So if my axis of symmetry is at 3, 2 units to the left of that would be 1, 2 units to the right of that would be 5. So those are the two numbers I'm going to substitute in to help me get the shape of my graph. So y equals 1 minus 3 quantity squared plus 2. Y equals negative 2 quantity squared plus 2. So y equals 4 plus 2, which is 6. So one of my ordered pairs should be 1, 6. So I substitute in the 5. So y equals 5 minus 3 quantity squared plus 2. Y equals 2 squared plus 2. Y equals 4 plus 2, which equals 6. So that worked out how I anticipated. So 1, 6 and 5, 6. And again, helps me get the shape of my graph. Now the next two that we are going to do, you're going to have to be careful because there's a negative outside of the parentheses. So we have to make sure that we're accounting for that when we're doing our math. So number 5, y equals, and remember that's like saying negative 1 times the quantity x plus 3 squared plus 4. So in this case, a would equal negative 1. So if a is negative, which direction will this open? Yeah, this opens down. And here's where we have x plus 3. So if it's x plus 3, that means the h is going to equal -3. H will be opposite of what you see in the parentheses. And K will be 4. So the vertex here is the ordered pair -3, +4. Which again, then that tells me where my axis of symmetry is, because the vertex has to be on that line. So if the vertex is at -3, 2 units to the left of that would be -5. 2 units to the right of that would be -1. So those are the 2 points that I'm going to substitute in to be able to help me get the shape of this graph. And this is where you have to be careful. You have to account for that negative outside. So y equals -1 times -5 plus 3 quantity squared plus 4. You have to make sure and account for that negative. So y equals -1 times the quantity -2 squared plus 4. -1 times 4 plus 4. So -4 plus 4 is 0. And now we need to do the same thing and substitute in the -1. So -1 times the quantity -1 plus 3 quantity squared plus 4. -1 times the quantity 2 squared plus 4. -1 times 4 plus 4. So -4 plus 4 is 0. So they did match up like I expect them to, but you should always do the math to make sure you have not made a mistake on one of them. Don't assume until you can mathematically prove that they match up. So -5, 0, and -1, 0 help me get the shape of my graph, and I can sketch it in. And number 6 is going to be very similar in nature to what we just did in number 5. Again, you have that negative outside the parentheses that you have to take into account. Remembering that's really like saying there's a -1 out there. So here A equals -1. H would equal +2. And K would be -4. So my vertex would be the ordered pair 2, -4. And because A is negative, I know that this is going to open down. So if I graph 2, negative 4 as my vertex, and again, that means I also know where my axis of symmetry is. So 2 units to the left of 2 would be 0. 2 units to the right would be 4. So those are the two numbers that I'm going to substitute in. So y equals negative 1 times 0 minus 2 quantity squared minus 4. Y equals negative 1 times the quantity negative 2 squared minus 4. Negative 1 times 4 minus 4. So negative 4 minus 4, which is negative 8. And that makes sense because I expect this to open downward. So to get 0, negative 8 makes sense. And now I'm going to substitute in the 4. So y equals negative 1 times 4 minus 2 quantity squared minus 4. Negative 1 times 2 squared minus 4. Negative 1 times 4 minus 4. Negative 4 minus 4 is negative 8, so it does match. So 0, negative 8, and 4, negative 8. And there's the shape of my graph. Now, in the next set of examples, we're just going to determine which way it opens and where the vertex is. We don't have to graph it just to get that information. Because remember, we can determine that information just by looking at A, H, and K. That's what gets me that information on which direction it opens and what is my vertex. I just need to know the value of those 3 variables. So number 7, y equals the quantity x minus 4 squared plus 12. What would be the value of a in this one? 1. So a equals 1. What would be the value of h? If it's x minus 4, what does h equal? Positive 4. And k equals 12. So does this one open up or open down? A is positive, so does it open up or down? Up. So it opens up. And what is my vertex? The ordered pair, 4, 12. Number 8, y equals the quantity x plus 6 squared minus 3. What is the value of a? Remember, it's whatever's outside the parentheses. That's an equal sign, not a negative. So this one, A would equal 1. What about H? If it's x plus 6, what do we know about H? Negative 6. And K would be just what we see at negative 3. So does this one open up or open down? A is positive, so this opens up. And my vertex would be the negative 6, negative 3. Just bringing H and K together. Number 9, y equals negative 1 times the quantity x plus 4 squared minus 9. So because that negative is outside the parentheses here, this is where A would equal negative 1. We have x plus 4, so H would equal negative 4. And K equals negative 9. If A is negative, does this open up or down? And this opens down. And my vertex is negative 4, negative 9. Number 10, y equals negative 1 times the quantity x minus 5 squared minus 22. So again, A equals negative 1. Here, H would equal positive 5 because it's x minus 5. And K equals negative 22. Again, the same as number 9, A is negative, so this is going to open down. And my vertex is at 5, negative 22. And then there will be a set of questions like we had yesterday, just asking how different numbers affect the graph. This is where you have to understand your A, your H, and your K, how they impact the graph. So number 11, what does 4 do in the following equation? Well, the 4 is out front here, so this is telling me that A equals 4. If it's 4, it opens upward. That's not one of the choices, but I know that A is greater than 1. And from yesterday, if A is greater than 1, what do I know? Does that make the graph wider or narrower? Narrower. It's a faster rate of growth. So if A is greater than 1, we have vertical stretch. Number 12, what does the negative 1 do in the following equation? Again, the negative 1 is out here in front of the parentheses. So in this case, A is negative 1. And how this was worded on this particular one. When A is negative 1, we know it opens down. And that's the same thing as saying translating it across the x-axis or flipping it. That means the same as opens down. (13) What does the 3 do in the following equation? And this is where we've got to be careful. The 3 is in here, as a plus 3. If it's a plus 3, that means that h equals negative 3. If h is negative 3, does that shift up, shift down, shift right, or shift left? Left. It's a horizontal shift. It's negative. So that is going to shift left. And in this one, what does the 1 do? And when we're talking, I meant this 1 at the end here. I should have been more specific on that one or changed the numbers. Which means that k is 1 in this case. Does that shift left, shift right, shift up, shift down? And this one is going to be a shift up. And I'll put a little note here for those that are struggling with this. H shifts the graph left or right. K shifts the graph up or down. So we have to know the effect that those letters have on the graph. What will happen to the graph based on those numbers?